Good morning again.
Good morning.
Good morning.
Okay, I'm fine. We are going to see in our today's discussion pressure in liquid, pressure in liquid. Before that, what do you have seen in our previous time? Do you remember what you have seen?
We
Yes,
saw about
what you have
pressure.
seen in our previous time.
Of Pascal of pressure.
Pressure. Okay, we have seen the definition of pressure. So, what is pressure mean? What's pressure mean?
Pressure is
Pressure
an
is what?
effect
Force
on
acting on a unit area.
surface.
Yes, yes. Pressure is
An effect
Fix
when a force is applied
first when
on
force
a
is applied
surface.
on a surface.
okay. Yeah, pressure is a force applied in a unit area. Okay, force divided by a given area is what we call pressure. And we have seen pressure. The SI unit of pressure is Pascal. That means Newton per meter square, and so on. And we have seen some problems which related with pressure. So in our today discussion, we are going to see liquid pressure. Okay, liquid pressure. Liquid pressure depend on the height or the depth of the liquids and the density of the liquid. Okay, the density of the liquid. That means a denser liquid have high pressure, and as light denser, or the liquid which to have small density have small pressure. So by this concept we will see, for example, density of the liquid is equal to density times pressure of the liquid is equal to density times gravitational acceleration times height or the depth of the liquid. Depending on this one, we are going to see some question. Okay, you are going to see some question. So if you see from this from your screen, the following are some common characteristics of liquid. Liquid to have some characteristic. Okay, some characteristics. For example, liquids have no definite shape. That means it takes what? It takes the shape of what?
Their
The shape of
container.
what? The shape of the container. It takes the shape of the container. The container. Okay, for example, if you take the same liquid, or for example, if you take water, if you add in rectangular block, in a rectangular shaped box, it takes the shape of the rectangular shaped box. And if you add again that water into a cylindrical form of container, it takes the shape of cylindrical form. Okay, it takes the shape of cylindrical form. Therefore, liquids have no definite shape. That means it takes the shape of the container which it exists. And the liquid have definite volume, mass, and the weight. It do have their own volume, mass, and the weight. So it do have definite volume. Okay, it do have definite volume. The other one is the molecules of liquid are relatively free to move than molecules of solid. For example, if you take the molecules of solid, it is fixed at one point. It is not free to move. Okay, it is not free to move. But in case of the liquids, it is somewhat free to move. Okay, free to move, free to move. The other one is liquids are less denser than solid. Okay, liquids are less denser than the solid or the molecules of solid. That means liquids, solid are denser than, for example, this shows or this implies solid are denser than liquid. Okay, liquids. Solids are denser than liquids. Therefore, the liquids are less denser than solid. That means solids are denser than liquids. The other point, liquids exert pressure on the wall of the container in all direction. For example, if you take the pressure in the liquids, in all direction, it's applied on the container. It applies the pressure on the container. Therefore, the pressure in the liquid are in all direction. The other point, what you must know, as I have said above, liquids pressure depend on the depth of the liquids, that is the liquid pressure, and that means what? Increases with increase the depth and decreases with the depth decreases. Therefore, it depends on the depth of the liquid. For example, if you take and you will fill such type of containers by such type of, for example, if you take this one is as water or sub-liquids. If this one container do have some holes, for example, at A point and B point as the end C point, and it seems like this one, okay? It seems like this one. Because of what? Because of the height of C is greater than height of B. Height of B is greater than height of A. Have you seen? Because they depend, the pressure which is exerted on this liquid depend on what? Depend on the depth of this liquid, okay? Depend on this, the depth of this liquid. So the pressure in the liquids depend on what? Depend on the pressure in the liquid depend on the depth of the liquid. That means increase with increase the depth and decrease with decrease in the depth. That means they do have direct relation. The other point, liquid pressure also depend on the density of the liquid. For example, density of an object is constant. For example, density of water is constant, density of iron is constant, density of aluminum is constant. Therefore, they depend on the density of the liquid. For example, density of liquids, they do have their own density. If you take, for example, water is, the density of water is 1000 kilogram per meter cube. 1000 kilogram per meter cube. Therefore, the other point which the density of the pressure of liquid depend on it is what? Density of the liquid. That means denser liquid, the higher pressure, okay? Denser liquid, the higher pressure. Denser liquid, the higher pressure. And the less in density have smaller the pressure, okay? Therefore, pressure depend on what? On height and or depth and density of the liquid, okay? Density of the liquid. So by rearranging this formula, for example, pressure is equal to rho gh, okay? Density plus gravitational acceleration plus depth or then height on the liquid, okay? Height in the liquid. So if you take pressure, liquid pressure is equal to density of the liquid times gravitational acceleration plus depth, okay? Gravitational acceleration plus depth. For example, in our previous time, if you remember, this one is the same, for example. If this one is the same with the previous one. Force over what? Pressure is equal to applied force over what? Area, okay? Applied force over area. This equation and the previous one are equal. Let us see, okay? Let us see. They are equal. What? For example, if you take weight, in case of force is equal to, from this one, force is equal to mg, okay? Mg. Therefore, mg over area, okay? Mg over area. mg over area. What do you know the relationship between mass, density, and the volume? What do you know? Huh? What do you know the formula of density? In our previous time, I think we have seen density is equal to what?
Mass over volume.
Yes, density is equal to mass over
Mass over volume.
volume.
Mass over volume.
Mass over volume. Excellent. Density is equal to mass divided by volume. From this one again, from this one, mass is equal to what? Mass is equal to crisscross. Okay, multiply crisscross.
Density
Mass
times
equal to
volume.
density times volume. Excellent. Density times volume. Therefore, instead of mass, we can use density times volume. Okay, density times volume.
Volume.
Are you with me?
Yes.
Therefore, let us insert density times volume times gravitational acceleration over what? Over area. Again, we do have area. Okay. Again, we do have area. Okay, the other one, for example, volume is equal to length times width times what? In case of, for example, some solid geometry like rectangular shaped body and times height, okay? Times height. Therefore, look, this one means length times width is equal to area, okay? Area. Therefore, volume is equal to area times height, okay? Have you see? Clear or not?
Clear.
This one means clear area, okay? Length times width means area, okay? Therefore, volume is equal to what? Volume is equal to area times height, okay?
Area times height.
Okay, instead of volume, look, instead of volume, density times area times height times gravitational acceleration over what? The first area, okay? The first area. Therefore, look, area can be cancelled by area. Area can be cancelled by area. Therefore, our pressure is equal to rho gh, okay? Rho gh. That means, look, when P is pressure, this one is density, and G is gravitational acceleration, and H is depth of water, okay? Depth or height, okay? Depth or height. Therefore, liquid pressure is equal to density times gravitational acceleration times what? Height, okay? Gravitational acceleration times height. Have you seen? Therefore, pressure in liquid depend on density of the liquid and the depth of the liquid because of gravitational acceleration is constant, 9.8 meter per second. It depends on what? Density and the height, okay? It depends on density and the height. The other point, what you must know from this one, pressure is equal to density times gravitational acceleration times height. From this one, density is equal to pressure over GH and depth is equal to from this one what? Or height is equal to from this formula. What's the height? Not understood. Okay, I think there was a connection problem. Let us continue. Let us continue. What is the depth of from this formula? How we can calculate for the depth for height? Huh? Yes, from this formula, how we can calculate for the heights? Huh? Pressure is equal to density times gravitational acceleration times height or depth. From this one, density is equal to pressure divided by or over GH. That means gravitational acceleration times height. What about heights? What about heights? What about heights?
Density times gravity.
Pressure over density times gravity. Yeah, you are right. Thank you. Therefore, by rearranging this formula, we can calculate equations which related with the pressure of liquid. Okay, we can rearrange and we can calculate the equation which related with liquid's pressure. Okay, or liquid pressure. Therefore, what you must know in our today discussion under this subtopic, pressure of or liquid pressure depend on density of the liquid and the depth of the liquid. Okay, depth of the liquid. That means denser liquid has high pressure, and which a liquid which it is depth is high again, it do have high pressure. Okay, high pressure. Therefore, the relationship between the pressure and the density of the liquid and the depth of the liquids are what? Direct relation. Okay, or proportional. As for example, liquid of the pressure increases, the pressure of the liquid increases. As the density of the liquid increases, the pressure in liquid increases. Again, as the depth of the liquid increases, it is pressure again increases. Okay, increases. Therefore, by using this formula, we can find pressure in the liquid. Okay, pressure in the liquids. Clear?
Clear.
Clear or not?
Clear.
Yes.
Okay. Therefore, pressure in liquid is equal to rho H, density times gravitational acceleration times height or depth of the liquid. Okay. Let us do some examples. For example, question number 1. What's the pressure exerted by a liquid having a density of 1000 kilogram per meter cube at the depth of 4 meter? Gravitational acceleration is equal to 9.8 meter per second square. Okay, 9.8 meter per second square. What's the pressure? Yes, try it. Okay, how many? Try this question. Yes, what is the answer?
39,200 Pascal.
39,200 Pascal. It can be, okay? It can be. It can be. It can be. Is there another answer? Another answer?
No.
39,200 Pascal. Jason?
Yes.
Okay, Jason, let us see together to check. For example, we do have density 1000 kilogram per meter cube. What about the depth or height? 4 meter. 4 meter. The other gravitational acceleration is equal to 9.8 meter per second square. Therefore, require this pressure. Okay, what is pressure? Pressure is equal to
Distance.
density times gravitational acceleration times what?
Times
8. Therefore, 1000 kilogram per meter cube times 9.8 meter per second square times 4 what? Meter. For example, this meter can be cancelled by 2 meter, okay? You will get only 1 meter. Only 1 meter. Only 1 meter. That means it gives for you kilogram per second per meter, okay? That it gives for you as the last Pascal, okay? Therefore, if you cancel this one, it gives for you 98. 98 times, for example, 98 times 4. 98 times 4 times 100. 98 times 4, how many? I think 392 times 100 kilogram per meter or meter cube times meter square per second square, which gives for you, I think, 39,200 Pascal, okay? 200 Pascal. Have you seen? Or you can say 3.29 times 10 to the power of 4 Pascal. Or if you wanted to write this one, 1, 2, 3, 4. 3.92 times 10 to the power of what? 4 Pascal. Okay, they are equal. They are equal. Therefore, the pressure of that liquid is 39,200 Pascal.
Pascal.
Okay. Let us see question number 2. If the pressure at the bottom of the container is 500 Pascal for a water of density 1000 kilogram. What is the depth? What's the depth? For example, in this case, use gravitational acceleration 10 meter per second square. 10 meter per second square. Okay. Try. If the pressure of at the bottom of a container is 500 Pascal for a water of density 1000 kilogram per meter cube, what is the depth of the water? What is the depth of the water? Try. What's the answer?
Mr. Andy.
Yes.
0.05 meter.
0.05 meter. Okay, they
Yeah.
can be
1 over
1 over
2.
1 over
1 over 2.
yes, 1 over what?
1 over 2.
I think 1 over 2, 0.5.
Yeah.
0.5. Okay, it can be. Let us see together ladder.
0.05 meter.
Is there another?
0.05
meter.
Okay, 0.05 meter.
1 over 20 meter.
Okay. Number one, we will see together, okay? We will see together. Okay. What is given? We do have pressure. Pressure is given for us, okay?
Yes.
500 Pascal. What about another given for you?
Distance.
Density. Density is equal to, okay, density is given for you. Kilogram per meter cube. Another given for us, gravitational acceleration. Gravitational acceleration 10 meter per second square. They require this height or depth of the water, okay? Depth of the water. Therefore, from the previous one, depth of the water is equal to pressure divided by what? Gravitational acceleration times what? Density, okay? Density. Density. Isn't it?
Yes.
Yes.
The formula is correct. There, instead of pressure, we do have how many? 500 Pascal. What about your pressure?
1000 times 10.
1000 kilogram per meter cube times what is the gravitational acceleration? I think 10
meter per second.
meter
Meter
per
per second.
second square. Okay. Therefore, in our above equation, Pascal is equal to kilogram per meter cube over per second square. Okay. This, when we simplify the unit given for us, we will get 1 meter. Okay, 1 meter. So by 20 cancel by 2. Okay, therefore 5 over 10 times 10, 100. 100 kilogram, 1 meter cancelled by 1 meter from this one. Therefore, kilogram per meter cube second square. Okay, second square. Again, we do have Pascal at the above. Therefore, 5 divided by 100. 5 divided by 100.
0.05.
0.05.
0.05 Pascal per kilogram per meter cube per second cube means meter, okay? Meter. It gives for you meter. Therefore, 0.05 meter. The depth of this water is 0.05 meter. How you see? First, we have calculated about pressure. From pressure, you can get height and the density of the liquid, okay? The density of the liquid, the density of the liquid. I think this question is clear for you.
Yes.
Huh? Clear or not?
Clear.
Clear?
Clear.
Okay, let us add another one question for you. Let us add another one question for you. The pressure exerted on the wall of the container at the height of 5 meters is 294 Pascal, okay? 94 Pascal. What is the density of the liquid? Gravitational acceleration is equal to 9.8 meter per second square. The required one is what? Density, okay? Density. Find from this equation. Find the density of this equation. Yes? Yes. What about the answer?
6 kilogram per meter cube.
What about the answer?
6, Mister.
6.
6 kilogram per meter cube.
6 kilogram per meter cube, okay? It can be, it can be. What about others? What about other students? Huh? What about other students? No one? No one? Or the same answer? The same answer?
Yes. Yes.
The same answer? Okay.
Yes.
Let us see. Let us see together. Let us see together. Thank you. What is given for us? Given height is given for you. How many? 5 meter. What about another? Pressure.
Hey,
Pressure is given for you. How many?
29.
How many?
294.
294 Pascal. What about another? The gravitational acceleration is given for you.
9.8 meter per
9.8
second.
meter per second square.
9.8 meter per second square. Okay, required.
Distance.
Required is what? Density, okay? Density of the liquid. Density of the liquid. Solution, let us see. Solution. Density of the liquid from the pressure in liquid, density of the liquid from the pressure in liquid is equal to pressure of the liquid times what? Over gravitational acceleration
Times
height. Okay. Okay, thank you. We do have 294 Pascal over
9.8 times 5.
9.8 meter per second square times 5
5
meter.
meters.
Okay. This means 294 Pascal
Over 49.
over 40.
49.
Yeah,
49.
49 meter square per second square. Okay, meter square per second square. So if you see in above equation, for example, if you calculate the dimension of Pascal, it gives for you kilogram per meter cube times meter square per second square. Okay, that means, for example, Pascal is equal to kilogram per meter cube times meter square per second square. Therefore, meter square per second square cancelled by meter square per second square. Therefore, the rest for us, or the unit rest for us, is equal to how many?
Kilogram per meter cube.
6. Yeah, 6 kilogram per meter cube. Okay. How you see? We can rearrange and define for all of them. Okay. For find all of them. So if you can understand this one, I think enough for you, or I can add one question for you. But the same mind, I think, the same mind. For example, have you seen this question? A liquid of 1000 kilogram per meter cube exerts of 4,950 Pascal on the bottom of the container. Find the depth of the liquid. Okay, again, gravitational acceleration given for you is how many? 9.8 meter per second. Okay, find it. This one is meter cube. Okay, per meter cube.
ها؟ أربع ساعات كسر.
Have you tried, please? The times, I think, up. Try.
0.51.
The same manner, okay? The same step with the first one, or on the second equation. 5. For example, what is given for you? I think pressure is, I think, pressure is given for you how many? This one is 1000 kilogram per meter cube. What about your pressure? Pressure is equal to 4,950 Pascal. Again, gravitational acceleration is given for you 9.8
meter per second.
meter per second. Therefore, required is what? What is required? Depth or the height? Height is equal to pressure over
Times
density times gravitational acceleration. Okay, gravitational acceleration. Therefore, 4,950 Pascal divide by
1000
1000
meter cube.
kilogram per meter
Cube.
cube times 9.8 meter per. Therefore, this cancel and you can multiply 4,950 Pascal divide by how many? 900, 9,000,
800
9,800 kilogram per meter cube times meter per second.
Second.
So
0 by
simplify
0.
0 by 0, then simplify by 5 you can get around what?
0.505. 0.5.
0.5, 0.51.
0.5451
Yeah, 1/2 or 0.5 watts meter, okay? 0.5
meter.
meter. So in our today's discussion, I hope you have understand how we can calculate the pressure in liquids depending on the given density and the depth of the liquid, okay? The depth of the liquid. So we will stop on this point. We will continue next spread atmospheric pressure, okay? Atmospheric pressure. Enough in our today's discussion. We will stop on this point.
Goodbye, teacher. See you tomorrow. Bye.